So back again today. I'm gonna code up the rest of clip, which is just the training loop. I'm not going to actually code the full training loop because I've done that many times in many of my videos, and it looks essentially the same except for a few additions that are unique to clip, such as like the attention mask, but the general format is the same. It's, training, which involves, back propagation and then updating some metrics and then running through a validation loop. I mean, it's the same. If you've watched any of my videos in the past, you'll see me coding the full training loop. I need to save time because this has already been quite a long series, and I don't want to, I don't know. I like to reserve space for information that's unique to this particular video. So yeah, let's get started. I'm just gonna basically, okay, so basically what is unique is I need to create a custom PyTorch dataset, Flickr 30K, for the Flickr 30K data, and I need to create a custom custom batch collator. So just because, because the data set is images and captions and PyTorch doesn't handle that natively. So yeah, I just need to create a custom data set, and then it needs to know how to collate a batch when we're doing the training loop. So for the rest, I'll briefly go over the important parts, and then I'll leave it up to the viewer to, dig into it and run the code. But so yeah, let's get started. So all right, so we have all these helper functions and, loading, getting the data set, getting the train and validation loader, just very similar to what I've had in my previous videos. It's just maybe it's a little bit different when it comes to clip, but essentially the same. I still have an environment file. Where are these? Config files, sorry, not environment files, config files, local server. And, right, so train test model, it's going to call weights and biases, initialize weights and biases. We're going to get the data set, and we're going to get the train and validation loader. We need a tokenizer to get the vocab size because we need to set that on clip. We need to set the vocab size on clip. And then the rest of it is mostly the same. I don't have a bunch of bells and whistles on this, right? It's just standard Atom W. And I'm just calculating loss for right now. I'm just tracking loss. I mean, there are other metrics I can track, but I don't think I'm going to dig into that for now just because I can't get the model to converge, right? Like I discussed in the last video, I just don't have nearly enough data, and I don't have the compute resources or the money to run that kind of project. I mean, you're talking about probably hundreds of thousands of dollars, maybe less. I mean, to show some kind of convergence. But yeah, it would be money that I don't have right now. So I don't know if I want to go into talking about the metrics we can track. Yeah, I think I just kind of want to move on from clip for now. I think I've done enough in this. Let's continue on with this for today. So yeah, I mean, again, standard training loop. Take a look at it, download the code from the repo, take a look at it. So let's code up, okay, first let's do the data set. So basically what you need to know is, I do think it is important to know this because if you want to work with PyTorch and build cool models, you're probably going to have to know how to build a custom data set and a custom collator at some point. So data set, essentially you're going to have your data living on the file system somewhere, and your custom data set class is going to know how to read the data from the file system into a batch. So right here, when this line is run, oh, I haven't used attention masks yet. Interesting. We can try that out this time. Well, maybe, yeah, we'll see. Anyways, so when this line is called, so when this line is called, the images and the input IDs for the images and the input IDs, which are we can call these captions. I think that's a bit clearer. Yeah, that's a bit clearer. So we'll call those captions. So when this line is run, the dataset class is called, and the get item function is run one time for the total number of elements in the batch, which is set by the data loader. So to populate these three items right here, there's going to be a function called get item. That's called, and it's going to return an image, the caption, and an attention. Well, actually, no, sorry. It's going to return an image and a caption, and then this function is going to be called once for every element in the batch, and that's going to return an image, a caption, an image, a tensor of images, a tensor of captions, and a tensor of attention masks. And this is going to return an image and a single image and a single caption. So whenever this is called, get item is going to be called once for the number of elements in the batch, and it's going to return, let's say it's 10, and it's going to return 10 image caption pairs, and then collate batch is going to be called on that entire data set, and it's going to return an image tensor, a caption tensor, and an attention mask tensor. So we're gonna populate these right now. Okay. Okay, so first let me talk about the data. So, okay, so I have this. So I downloaded there's a Flickr 30K repository you can download. It's literally called this. I think it's this right here. I just did a git clone on this repo. And then there's something else I use. There's another tool, there's another script I use. I'll have to download images. I don't think that's in this repo. I got it from somewhere, I don't know where, but I'll include this download images script I'll include this script in the code. Let me just do that now, actually. Okay, so now that's there. Oh, okay, so if you clone this repo, this download images won't be in there. It won't contain the images, but it will contain the captions. Actually, now that I think about it, I'm like, why did I even? Yeah, I went through a whole process trying to find out how to get this data. So you probably don't even need to clone the repo. I think if you run download images, it'll download the images and the captions. Anyways, I ran download images, and then I put them under this Flickr 30K folder. And I think when you run download images, it downloads zip files. Yeah, and then it unzips them. Yeah, into the Flickr 30. So this script unzips them into the Flickr 30. So honestly, I don't even think you need this repo. I mean, you can just run this download images, and then it'll unzip them into this Flickr 30K. And then in your config file, you just need to set data root to wherever you have your Flickr 30K folder. Wherever you have this folder located, you need to set it to basically PWD. And then so when you create this Flickr 30K dataset class, you'll set images root in the captions file and the transform function you want to use. So anyways, images root, captions file, transform. So I'm going to set this to images root. Now, so in this, okay, so in this, in the constructor for this class, when it's initialized, we basically need to so with this data, so right now in your file system, you're going to have all the images listed, all the images here, and then your captions is going to be just a comment separated list of image ID and a caption, and there are going to be multiple captions for each image ID, right? So when we create the data set, actually, no, what we want to do, no, what we want to do is we want to create a dictionary that has image ID and then a list of captions, and then when get item is called, that's when we want to return. Get item is going to be called with an index. That's when we want to randomly select the caption to return, and we'll return a single image caption pair. So if we look at this list, right, we just have to parse. Essentially, what we're going to do now is just parse this into a dictionary. So captions file. for line in F. Strip it first. I already know what I want to do for this file, so I've already parsed this file. So I'm just going to do some parsing stuff. So if we get a faulty line, continue. So we're going to say split on the white space with a minimum time of a minimum number of times of 1. And if the length of parts is less than 2, then we're going to continue again. So it's just another faulty line. We're going to say image ID caption. So this is what we're actually parsing, right? So parts, right? So we just split this. And then we just also looked out for any faulty characters like hashtags or anything. So we just split this. Now we just need to remove. Now we need to remove some characters. So what do I want to do? Caption. Okay. All right, this is max split, not min split. Max split, so we're only splitting, and it's the first occurrence, so. This is removing any hashtag that's there. And I do recall there being some hashtags and me having trouble with that. We're gonna split, we're gonna strip. Then we're gonna strip it. We're gonna strip it of commas. We're gonna strip it of that character. Let's strip it of those and then strip it commas. And we'll strip it of any white spaces. And then all right. Well, yeah, I already stripped it of white spaces, so and so now I'm gonna say the dictionary I'm gonna add, right? I'm gonna say set default to be, so this is basically going to, if the key exists, This is a key now. This is file name, file name. So if the key exists, return it. Otherwise, return an empty list, and then append to that empty list. So if the key exists, return the list that's associated with the key. Otherwise, return a list, and then that's going to append caption. So this will just keep adding all the captions for that image ID. And then create a list of file names that will contain all, which are just the keys of this dictionary. And now get item, it's going to, so okay, so we have image ID. So now, so this function we need to return for an index, right? So for an image ID, we need to return the actual image and randomly select the caption when we're populating this batch, right? So if the batch size is 10, this get item function is going to be called 10 times, right? So so image, it's a pillow image, open file path. So we need, and we're going to convert that to it's just a pillow convention. We're just saying convert it to a RGB type of pillow image. We need 3 channels. So this path is going to be, we're going to join self images root, right, which is the data root combined. It's the location right here of this images folder. I'm going to join that with the file name, so the index, the image ID, and then we get the image, and then we need a caption. Well, then we need to apply the transforms. Oh, this needs, I don't need caption file, transform. It's not none. Boom. So this is where we apply the transform to the image, like if we have augmentations or something like that. And then we need to caption, it's going to be random.choice self.captions. File name. Right. So image caption. Okay. So now click Collator. So it's going to have tokenizer name, length and device default CPU. So the tokenizer is going to be, we'll get from HuggingFace, and it'll be OpenAI's default clip tokenizer. The other option is we have to manually train the tokenizer ourselves, which we can do, but yeah, not this time. Not this time. OpenAI clip ZIT that's 32, something like that. We'll see. T base past 32. I think that's it. Okay, so I guess I don't need to make this an instance variable since it's already defined at the top. Oh well, let's keep it the same. So, okay, so now we already called get item, 10 times if batch size is 10, right? So we have a list of image caption pairs, and now PyTorch is gonna, when it's collating the batch, it's gonna call this function. It's gonna call this function on a list of image caption pairs, right? So that's what the batch is gonna be. It's gonna be a list of image caption pairs. So what we want to return is images, captions, attention masks. So images is gonna, images and captions, it's gonna be, we're just gonna unpack this batch and then zip it, and it's gonna give us this images captions list. And then tokenizer name. So tokenizer, so this clip tokenizer is from transform. Oh, it's from transformer. It's not from HuggingFace. Yeah, that's right. From pre-trained. Tokenizer. I think we call tokenize, right? We want to tokenize these captions. So let's do this. Tokenizer. Wait. Oh, I see why I kept the input IDs. So, yeah. We need to wrap that in a list because zip gives us a generator. Devices. Adding. Return tensors. Return PyTorch object. Padding equals truncate. Padding equals max length. Truncation equals true. So what this means is we're basically going to pad up to the max length, which is going to be 77. So we're going to truncate. So basically we're going to truncate where so if the caption doesn't reach the max length, we're going to truncate and pad up to the max length. And then we're going to return a PyTorch tensor. That's what PT is. And then tension masks equals tokenize dot and then input IDs. I think that's right. I think this is right. Oh, let's try running this actually. I haven't run this in a while, but let's give this a shot and then we can place a breakpoint here and see what we get. Num heads and heads. Image size. channels. Embed dim. Let's just look at this. Image size and channel embed dim, pet size drop out, text depth, and heads, vocab size. Vision depth. Be okay. Run it again. We get the vocab size from the tokenizer, which should be 49408. Wait, is it? Yeah, okay. Let's see. RGB. All right, so let's see. Images. Looks to be okay. Captions. I mean, if things weren't okay, I would have aired it out already. Yeah, that's why I called it image IDs or input IDs, because I should call it. Oh, there it is. S captions, token IDs, token IDs, token IDs, token IDs. Yeah, I like that more. Okay. Okay, so let's see, back to, right, so the attention masks look good, right? So things look okay. I'm gonna just let it train. Getting an error line. Tuple has no attribute 2. So I'm returning something that it doesn't, it's still a tuple for some reason when it should have been split. Okay, so oh, I see. Wait. Images. Oh. I need to stack this. I need to stack that into a tensor. Stack that into a tensor. I need to stack these into a tensor. These are already tensors. It's returning tensors here. I need to stack these into a tensor. Why it doesn't have a 2. It doesn't have it's just a tuple at this point. It doesn't have a 2 function. So I realized I made a major mistake. This is the second time I've messed up this logit scale. I don't know why I keep I think next time I should probably open the paper and just verify as I'm doing it. But anyways, first of all, this is supposed to be math.log. I was wondering why my losses were so large. And then we'll just change this to be logit scale. And then this will be logit scale. The last time I forgot to exponentiate, I forgot to do e to the power of the logit scale. And this time I forgot to take the log, which makes it changes the whole ability of the model to learn. It changes the whole model. So anyway, so when we run this, so we'll run the training, and we want to get a sense of, actually, let's pause this really quick. So we want to get a sense of what the losses could be. We have a batch size. We want to know what it's like for the model to learn at random. So we have a batch size of 32. Essentially, we do negative log times the probability of a uniform distribution, which is 1 over the number of elements in your batch. That gives us 1.5. No, that's not right. Oh, natural log. I forget, whenever we say log in machine learning, we always assume it's base E, but the rest of mathematics is like that. So 3.4. So if we run this, we should expect the model to be learning worse than random at first. Usually that's the case. And then we want the model to converge to something that's better at random, which we won't see obviously with this small amount of data locally, but also with the small amount of data in the Flickr 30K data set. Online, when I did a training run, I had it never converged to anything that was making predictions better than random. Here, yeah, so we can see the loss fluctuating probably around something that's worse than random for now. And I expect it to stay probably somewhere around there. Let's see what the average loss is for the entire batch. Sorry, for the entire epic. 4.04. Yeah, I mean, that's pretty much expected. So yeah, I just wanted to make sure for the folks that are following along closely, want to make sure that I corrected that. So this should be, we'll change this to say logic scale. I was really tired, I think, when I was making this, when I made the last video. And this is temperature, and then this is log of 1 over the temperature. And then we have to make sure that we do the natural log raised to the, sorry, we have to make sure that we do e raised to the power of that logic scale when we're calculating the similarity matrix. Cool. I did a few training runs on RunPod, and you know, I could never get it to converge to a number below what I know is below. I can never get it to converge to a number that's below the value that signifies it's training better than random or training at random. So I can never get it below that number. So it's just because, I mean, it's just not, you know, a model with, you know, six transformers as an encoder and six transformers for an image encoder and 6 transformers for a text decoder, which is 12 transformers total. That's a lot of transformers for 30,000 multimodal data points. Yeah, so I don't expect it to learn anything meaningful from this data, but this is our model. This is the full clip training code, full model code. It all works. I think I'm just gonna leave it here for now because, yeah, I kind of want to move on from this. I'm still trying to figure out. To be honest, I'm trying to figure out if I want to. Well, let's just wrap this up. So yeah, that's our clip training code. Next, I'm still trying to figure out if I want to follow through with this diffusion stuff. I don't know. I kind of lost steam. I'm a little bit more inspired to build some bigger, I don't know, build some more realistic LLMs. I built Nano GPT, but I want to build like tiny llama. Maybe I'll build llama 2 and then load the pre-trained weights and then start fine-tuning it, start coding up some LoRa and fine-tuning it on crypto data. I want to start building some agents on crypto data and see what kind of creative stuff I can come up with. Yeah, I don't know. Maybe I don't know. I'm not sure yet. But yeah, let's leave this clip stuff there. Unless someone posts questions, they're like, "Hey, I really want to see this. I really want to see that. I'm confused about this or that." Then I can dig into this and do some more work possibly. But for now, I don't know. I think I'm just gonna leave it there. But thanks for watching. Hope you learned something. Later.